Well, this is our Hello World program that we're going to be working on in this chapter. It's a very simple program, as you can see, but there's a lot going on there. And that's what we're going to be taking a look at. And there's a lot that we need to learn about our compiler and our programming environment. And this is a great little program to use. It's been around since the early 70s. And it is an excellent program just to get you going. And that's why Kernighan and Ritchie put it in the original C programming book. It's the one that's on page 6, if you have that white book that we talked about earlier. And we're going to take a look at it in maybe even more detail than you want to, but I guarantee you, if you really understand what this little tiny program is doing and how it does it, and how you need to do your tasks to get this program into your computer, get it compiled, get it linked, and get it to execute, you will have really accomplished something. And then at the end of chapter 2 here, then at the end of this section that has Hello World in it, we will give you a programming assignment. And you're going to take Hello World and you're going to change it on your own and compile it and run it and make it do something else. So that's the Hello World, very simple. And we're going to move on to getting it into the computer and compiling it and running it. And we'll examine every line later on as we go in a couple of lessons here. But I just wanted to introduce you to it and let you know that as simple as it looks, it really is important that we do this little program and that you understand what it's doing and how it does it, and we'll be on our way at C programming. Now we're going to enter Hello World into our system so that we can then have a compiler operate on it, both in Windows and in Linux. So let's follow along here and get this program entered. Let's go down and take a look at the program first. There it is. We have pound include, a space, a less than, stdio.h, a greater than. On the next line, you just press carriage return at the end there. On the next line, we have the word main, open close parentheses, and then we have a brace. That's a left brace that you see there between main and printf. And then printf itself, printf, which means print formatted. An open paren, double quotes. That's the one just next to your enter key there, double quotes. Hello space world, a backslash. Notice that's a backslash. That's the one that's above your enter key on the keyboard, not the one that's below the enter key. That's a forward slash. So we have a backslash, a little n, lowercase n. That means new line. Another double quotes, and then a close paren and a semicolon. Semicolon's very important. You'll drive yourself crazy by losing semicolons, I guarantee it. And then we have a close brace there at the bottom, and then another carriage return after that. The white space that you see around those braces and in front of printf are not all that important. The compiler ignores them. The only white space it cares about is in between hello and world, and since that's inside double quotes, it will leave it alone. It won't care about that. The space after the word include is important because that would run all together. So we need to pound include the standard IO there in the first line. So let's drop out of here to the system. And remember, in Windows, to start our environment, we need all programs. And then if your system's not set to scroll, we go down to Visual C++ 2005 Express Edition that we installed. We go over to Visual Studio Tools, and then the Visual Studio 2005 command prompt. Click on that, and that is going to drop us into our Visual Studio 8 VC directory. Now let's, for convenience, let's make ourselves a new directory. I usually put it in the root just to have it someplace convenient. So I go to the root, and we'll make a programming directory. And then we'll go to that directory. So now we're in our programming directory, and that's where we're going to put our files. We're not going to make a whole lot of files out here, some different programs as we go along, but it'll be okay to have them in the programming directory like this. We want to use a simple editor, and in this case we're going to use Notepad. It's real easy to work with. Everybody knows Notepad. It was put out there long time ago in the Windows system so that we would have something to type with. More importantly, Notepad will create files without putting extra characters in them. You can't use Word, you can't use Microsoft Write or any of those other kinds of programs because they put a lot of extra junk in there for formatting and things like that. You could use Word if you were careful and you always saved your program as a text file and never saved it as a document. First time you save it as a document and overwrite your files, you have to go back and reload it and change it and fix it, and it's just not worth it. So for what we're going to do, we're going to use Notepad, and we're going to call this hello.c. Very simple. Notepad, hello.c, enter. That brings up Notepad, and it says it can't find the hello.c. Do we want to create it? Well, that's good. Yes, we do want to create it. So now we are creating our program, and we'll type it in just as you could see on the other screen there, and it might even be behind this window. Let's see if we can find it. There it is. There's our include standardio.h. So let's put that in. Pound include less than stdio.h, and then a greater than, and we'll go down a line or two. It's not important. We just need to get to the next line. And now let's put our program in. We can see it sitting right there. Main, open, close parentheses. We can have a space in there if you want to. It's not going to bother anything. It's all a matter of personal style. So we have the word main. Now main is important because that's a function that the C compiler is always going to look for, and that the operating system always wants to have out there as the main beginning point of a program. A C program always has a main someplace. One of the biggest applications I ever worked on, main, was just one line, and it called another function that really did all the work. But main has to be there because that's the way it is. That's what C wants to see as the first function to call. And when we're defining a function, and that's what we're doing here, we're defining what main is going to do. The first thing that we put after the name of the function is an open brace. And that's our little brace there. We'll drop down one line, and let's go over a tab. I just press the tab key. You can put 3 or 4 spaces in there. 4 spaces is more typical. And you can see that my tabs go a little farther, but that just makes it easier to read. So now we'll put the word printf. Remember, that's for print formatted. Another open parentheses, because now we're going to give printf something, and that's what we want to be printed. And that is hello space, whoops, can't type, hello world. Backslant, N for new line, we said. Another quotes, close parentheses, and a semicolon. A semicolon out there on the end tells C that is the end of this line. This is a statement that you're telling C, consider this whole line as a single statement and do something with it. Drop down to the next line. Now we're finished defining our function and everything that it's going to do. So we close up the brace. It matches that other brace there at the top underneath the M, and we'll put another carriage return in just to kind of clean things up. So that gets the program into hello.c, and now we're going to do a file, save, that tucks it away on the disk, and a file, exit. Let's go back over to our Visual Studio command prompt, and let's do a directory now. There it is, hello.c. It's a whole 63 bytes long, and let's type it out so we can prove there it is. There's our pound include, our main, printf, Everything's there. It looks pretty good. The semicolon is where it's supposed to be. There's only one. There's not a semicolon after the main open close paren. Don't put one up there. That would be bad, and I'll tell you why later. So we have our program all entered. And that's all we wanted to try to do here, was to get our program into the system. We're going to compile it and run it in just a second. Let's switch over to Linux and do the same thing. Here's my VMware and my Ubuntu. There's my desktop, and we'll also let's make a directory, not change to it, called programming. Then we'll change to it. Now we're inside the programming, and here I'm going to use an editor that is called VI. And the VI editor, I suppose I should call it VI and not Vi. Some people don't like that, Unix gurus especially. The VI editor will give me a pretty simple editor. If you're a Linux person already, you might have Pico. You might use a different VI that comes with your system. There's a number of different editors. I'm kind of used to Vi or VI, and that's what I work with. So we will do hello.c, insert, and let's type in the program. It's going to be exactly the same program that we had over in Windows. There is no difference. I like to put the brace under there. VI is trying to help me out by moving things around for me because it thinks it knows what I'm doing. All the exact same instructions. I'm hitting backspace to get it to go back over there where I want it. So there's our same program, printf hello world. Nothing is different, and it's on a totally different operating system, different environment, editor, compiler, everything, but the language is the same, and that is what is important about C. We'll escape out of there, and then we will write that out. Now it's written. Now we'll quit. I'll do a directory here. There's our hello.c file after we did a directory, so we know it's there. And now let's take a look at it. We will cat the file out. There's our #include standard IO, main, printf. It's all the same. Now we have not compiled it yet. That's coming up next. Well, now that we have our program on the computer in source code, now we need to compile it into object code, let it be linked, and create an executable, and then run the executable. So let's do that on Windows first. We're going to compile and run our Hello World program that we just entered into the editor. We're going to do that with two commands, one cl space hello.c, and that's our compiler and linker, cl together. That's going to compile and link hello.c into object code, which we won't really see any file for that. And then it's going to create the executable. And it's going to assume that we want to call it hello. It'll take the first part of the file name, drop the .c off of it, and it's going to create a hello.exe on our Windows computer that we can then execute. So let's switch over to our DOS prompt that we created earlier. And there it is. It's same place that it was. Let me clear the screen here so you don't get too much of a peek. And let's look at our program. So we will type it out, show that it's still there. There's our #include, main, printf, hello world, everything we put in there. And now we'll compile and link it. cl space hello.c. And there's our compiler starting up. And hello.c was our source code right here that went in, and there's our linker starting up. Remember that we have the compiler creating the object code, which is hello.obj. It's right there. And there's our linker that was automatically started up, and it was told to make the output hello.exe. That's all by default and automatic. And if we do a directory now, there it is. There's our original source code that we created, hello.c, and there's our object code that was just now created in the middle, and there's our hello.exe, our executable, which is 53K. So a lot of other code was brought in there to get this program to work. And now to run it, of course, we just type hello, and there's our output, hello world. And notice that there's a blank line after hello world right here, because that's our new line that we had. We'll look at the program again. We had our \n, and that's the new line, and that's that blank line right there underneath hello world. So we see that we can actually enter a program, compile it, and link it. No errors. It did what it was supposed to do. Excellent. Now let's move on to our next slide here. And we're going to do the same thing, compile and run hello world in the Linux environment. And in Linux, we have two different ways that we can do this. One is with the cc hello.c. That's our C compiler. Remember, that's the same place as the GCC or G++ that we looked at. It's the same program that's going to be run, but we just use the CC because that's old school for a C compiler. And we'll cc hello.c, and then we run the program by executing a.out, because a.out is the default name of the executable produced by the Unix C compiler or Linux C compiler. A.out was the name of the default name of the output of the assembler that created the first C compiler back in the early 70s that we talked about earlier. So that used to be assembler.out or a.out, and the name has just stuck around. So that's why that's still there. And we need to tell Linux to run the program that's called a.out in the current directory, and that's the / that we put in front there. So /a.out will run our default output. Or we can direct the compiler to create an output file called hello, or of course whatever we want it to be called, with a cc space -o space hello, and that's what we're going to have our executable called, space hello.c, which again is our source code, just like it always is. And then of course we run it with /hello. Because that's what we wanted our output to be. So let's switch over to our VMware Ubuntu environment. Let me make it full screen so we can see it. And here we have our program, source code, #include, standardIO.h. Everything's exactly the same, just the way we typed it in. Let's compile it. Now, in Linux, no news is good news. So nothing was said, so we assume that it did its job. And there's a.out sitting over there. So that's our executable, and we can run it. A.out, hello world. There's a new line because our cursor is now on another line underneath, just the way it's supposed to be. Our command prompt is down there. If we didn't have the \n, our command prompt would be up there off the end of the D of hello world. Let's do it the other form, cc space -o, to direct our output to hello, and then our source, hello.c. Again, no news is good news. We do an ls, and there's our leftover a.out from before, and now we have an executable called hello, /hello to run it, and it also says hello world just the way that we assumed that it should. So now you've seen how to compile and run your first C program. You entered it, compile it, ran it, And next we will take a look at the program line by line, so we make sure we truly understand what it's doing, and talk about a few other things about that little tiny program and the importance of that little program to the bigger things that we're going to be doing. Now we're going to take a look at each line of our little Hello World program, just to make sure that we truly understand what is going on here, and to give you a little bit of just overview of what is happening in the program and what these different parts of the program are called. You're going to see all of these different areas that I talk about in more detail as we go on through the other chapters of our course here, but I want you to have a good idea of these different sections and how they kind of work together. The very first line there is a pound include. That pound hash mark in the first column there is a preprocessor directive. That's what we call that. There's a program that's part of the C compiler called the preprocessor that goes through and looks at the code and does a lot of replacements and checking and other work before the compiler is allowed to take the pre-processed source code and start creating a program with it, start creating object code from it. So that preprocessor directive, and we'll see that there's quite a few of them. Include is just the one we're using here. That directive is acted on before the compiler ever sees this program. And what we're doing here is we're including another file called the stdio.h. That's a header file. That .h is a standard in the C language to say that this is a header, and that is going to bring in information to support standard input and output. We don't do a lot with the standard input and output here in this particular program, but it's always a good idea to have this include because most programs will want to get information from the outside world and need to say things to the outside world. So standard I/O is typically needed. The less than and greater than symbols that you see around standard IO.h tell the preprocessor to look for this file in the common include area that's been defined to the compiler. We'll get into all of that when we talk about preprocessor directives and how that works. If we had double quotes around there, around standard I/O, we would be telling the preprocessor to look for the file in a location that we set up, not the normal include area where the preprocessor should look for common header files. So that's our preprocessor directive. The pound sign is usually in the first column, though it doesn't really have to be. You can have white space in front of that pound sign, so it can be moved over a few spaces. But for readability and the common look of C programs, that pound sign is almost always in that first column, just like you see it. And notice that there is not any kind of an end of line character there. There's no semicolon or anything like that after the standard IO.h and the greater than symbol there, the little arrow pointing to the right. Nothing has to end that line. This is main. This is our function definition or function declaration, we can say. And what we're doing here is we are defining what the main function will actually do if it is ever called. Now, we will be defining a lot of other functions as we go through the course. This one, though, is special because it is called main. That is a reserved name. We can't have any other functions called main. And if you have more than one, of course, that's an error. But the one main function of any program is the one that the operating system knows to start the program with. And the compiler, when it creates our object code, looks for that word main, looks for that function and says, okay, this is where things are going to start. And that's where your program will begin, and where it goes from there is up to you and your user and things like that. But the program will always start at main. There's an open and close parentheses right after main. There can be white space after the end. There can be a space there. I just haven't put one. It's okay if there's not. The parentheses will hold parameters that get passed from the outside world into main. And when we look at those kinds of, they're called arguments, when we look at those later, you'll get some detail on how to get information from the outside into your program. And that's how we interact with the World Wide Web as well. We take information in through through those parentheses and get it inside our program and do something with it. Notice also there is no semicolon after that closed parentheses because we are defining a function here. We are not calling it. We are not asking it to be performed. We are saying this is what is inside main and how main works when somebody eventually wants to call it. The open brace and close brace, that's a statement block. Main could be just one line. And in our case it is. It's just that little printf down there. So we really, technically, don't have to have the braces for this main because the single statement would be okay. Not a very useful program, though, if your main only has one line to it, but that's why you normally want the braces. So we have our open brace and close brace, which will contain all of the statements of this function. When I start programming, I put the open and close brace right next to each other, and then I hit enter a few times inside them and open up the space a little bit. That way I don't ever forget to put that closed brace on there, because that will cost you a lot of time looking around for a missing brace if you don't have those matched up. So that's our defining our function main with the braces. And now let's move on and look at what's inside there. There's our printf function. Now this is a function call. We are not saying here, of course, what printf does. We are asking it to do its job. We know what print formatted does. It's going to put stuff out to the outside world, and it's going to do it and make it nice and pretty. And it's also can pass all kinds of information from our program to the outside. When we get to printf, you'll see quite a bit about it. Printf is very powerful. It is included in the standard library that's included with the C compiler. It will always be there for you if it's a standard C compiler, so you can rely on it being included. So we have our printf. Again, there can be white space after the F and before the open paren. And then we have our parenthesis, and then the closed paren is on the other side over there before the semicolon, and that is a function call. That's calling printf. The hello world inside quotes there, that's just getting sent to the printf. And then the printf takes in whatever it's sent and acts on it. When we talk about printf, we'll see how it acts on all kinds of things that you can send it and tell it to do. Here it's pretty simple. It's just going to put this string, we call it, to the outside world. So let's keep going after our printf call. Now this hello world inside double quotes is a string literal. This is a number of characters one after the other, HELLO space WORLD, and then the \n is a single byte inside there. It's our carriage return, or actually new line is what this stands for, the \n, but that takes up a single character. And then we're going to find out later in string literals that there is really a null, an all zeros, all bits turned off byte stuck at the end of this thing. And that's hidden away in there. We don't see that right now, but that's how C strings are made up. They're a bunch of characters put together in memory with a null byte, a no value byte stuck at the end that lets C know where the string stops. And where it starts is the address of the beginning of the string, and we'll get to all that. I don't want to overload you with all that right now. But the hello world inside double quotes is going to be passed into printf so it can do something with it. Very important little semicolon out there at the end of the line. That is the end of that statement, end of line, end of statement character, has to be there for that printf to work. That says this is a piece of work that you need to do. We're not defining another function or anything like that. We're actually causing some work to be done. So that semicolon says this is a statement for you to execute, compiler, and that's the way the compiler will treat it. That is our whole program, as we've seen it, you've learned a lot. You've used preprocessor statements, you've defined a function, you've called a function, you've passed parameters, and you have your little statement in there. So good job. Good job. In our next piece of work here, we'll talk about a programming assignment, and then we'll have a program answer after that. So stay tuned. Alrighty, here's your first programming assignment coming up. I want you to go into your editor and modify your hello.c program to output hello, period, new line, my name is, new line, and then put your name in there. You can write your name if you want to, but it's a little more interesting if you get your own name in there. Nothing that we like to see more than our own name up in lights on a screen. And then put a period out at the end of that. I want you to try to think about the different ways that you could use printf and use different lines in your program. All you have to use is printf, but use it a couple of different ways to put your output on 3 different lines like that. I want you to try to do this once on 3 lines, and then I want you to go in and modify it again and see if you can change your printfs to put all of this information, hello, my name is, and your name, on just 1 line of output on the screen. And then get your cursor down there at the bottom again underneath the last line. And to do that, you're going to have to take away some characters that you've already used so that you get your output on 1 line. So remember, you have to use your editor and you have to edit the program, change it around. Don't forget your semicolons at the end of your new lines. And then you have to compile it. Well, of course, you have to save it, first of all, to the disk, and then get out of your editor. You'll have to compile it and link it. And our programs are going to do that for us automatically. And then you have to execute it so that you can see the output. Make sure that it ran. So take some time and practice getting in and out of the editor, using the compiler, looking at any errors that you might get, and trying to figure out what the compiler is telling you. Sometimes the compiler will throw an error, we call it, or tell you that there's a problem someplace after the problem, not right where the problem really is. We will look at that when we look more into how to program in C, how to really do some coding. But don't be fooled by your compiler and where it tells you there might be an error. But if you do it really well and you're careful, you won't have any errors. You won't have to worry about that. So there you go. There's your programming assignment, and we'll take a look at some possible answers because there's lots of ways to do this. There's probably as many ways to do this assignment as there are programmers out there. But I'll show you the way I would have done it here in just a minute. Well, that didn't take you very long to do. Are you sure you went out there into the editor and wrote your program and compiled it and tested it? We don't want you just turning in bench work here without actually doing the job. That's the only way to really learn how to program, is to get out there and code and compile and test and do it again. So here's our first answer to our programming assignment. There's our little program. We included standard I/O. Main is the same. Our hello world printf has been changed to hello period with a new line. The second line, the way I did it, is my name is, and then another new line so that we wind up on the next line down, and then my name and another new line so the cursor winds up underneath my name where it's supposed to be and not hanging off the end of it. Pretty simple, but you got to make sure you get those semicolons in there. You get all the double quotes where you want it. You use a \n and not a /. /n will print exactly that, a /n. A \n is called an escape sequence. And the escape sequence means turn this into something else. And the \n, of course, means new line. So that's why it goes down to the next line underneath where you just were printing. Let's take a look at our second answer. Here's answer 2, the same program, but remember this one is supposed to be all printed out on 1 line. We have the same 3 printfs, no reason to really change that, though we could, of course, put all of this text up inside the double quotes of just one single printf. But this was already this way, and if we're just doing maintenance programming, we don't want to mess with the structure of the code too much. We just want to make some simple changes, add the new functionality, compile, test, and get home. So there's our first printf, hello period space. So it spaces out some, and then our close quotes, my name is space, and then my name with a period, and now we have a single new line. You had to get rid of those new lines to make this work. Not exactly rocket science, but it is actual programming, no matter what. So that's our two answers for this chapter's programming assignment, and I hope that you did the work. If not, go do your homework right now. You get in and out of that editor and make those changes and compile and test. That's the only way to do it right. So thanks for watching, and let's move on into more of the C programming language.